Hey guys, this is the video for Unit 6, Lesson 1. Unit 6 is Systems of Equations, and the first lesson is Solving Systems by Graphing. So the learning target is students will determine if an ordered pair is a solution to a system of equations, and students will solve a system of equations through graphing. So let's kind of talk about what a systems of equations is and kind of some information about it first. So what is a system of equation? Well, a system of equations is a group of two or more equations that share the same variables. Okay. What does a solution to a system of equation look like? Well, a solution to a system of equation, which you'll notice I abbreviate with SoE, system of equations, is an ordered pair, right? Written with parentheses and x value, comma, y value. Wow, that's really sloppy. Ordered pair. Well, I don't know, whatever. And it says that satisfies all equations in the system. And what that means is that the ordered pair makes the equations, all the equations inside the system true if I was to substitute those values in. And we're going to do that here a little bit later. But it's also where the equations meet. Like if we were to graph them, it would be the point where they all meet. So the point where they meet. Oh my goodness. That should be an M. Meet. Okay, and then how are systems of equations solved? Well, we solve systems of equations in three ways. Last year, you guys learned how to solve them by graphing, which we're going to review today. And then you can also solve them by substitution method or an elimination method, which we're going to learn later in this unit. Okay, so let's review solving systems by graphing. Again, there are three different ways to solve a system of equations. The first is by graphing the equations. So what should you look for? You want to look for the point. Oh, sorry, I'm trying to read what I wrote here. The point where the lines meet. Oh yeah, I'm like half in the dark. Sorry. So you want to look for the point where the lines meet or cross. Why do I keep writing an N there? Meet or cross. Okay. And then one little thing you need to note is that before you graph the equations must be in slope-intercept form. So remember that's y equals mx plus b. Okay. All right, so let's do this. Let's do one. All right, what is the solution to this system of equations? And the equations are y equals negative x plus 3 and x minus 3y equals 3. So you can see that the first equation is in slope-intercept form already. We can just graph this one. My b or my y-intercept is 3, and my m or my slope is negative 1, right? There's a negative 1 there, which we want to make as a fraction, so we put it negative 1 over 1. Now this second equation needs to be solved and put into slope-intercept form. I'm actually going to write it in two different colors. It might be helpful if you do this in two different colors yourself as well, just because you're going to be graphing lines and stuff and you want to just know which one is which. I mean, you don't have to, obviously. Okay, so this one I need to solve for y or put it in slope-intercept form. So the first thing I'm going to do is subtract x from both sides. I'm going to get negative 3y equals negative x plus 3. Then divide everything by negative 3. And I'm going to get y equals 1/3 x minus 1. And then I can graph this. My b or my y-intercept is negative 1, and my slope or my m is 1 over 3. So I'm going to graph this one first. So -1, and then go up 1 over 3, 1, 2, 3, up 1, 1, 2, 3, and then find yourself a straight edge and make a straight line. Now you want these to be really accurate because you're trying to figure out where these lines meet or where they cross. And sometimes if your line isn't exactly like it should be, you won't be able to tell where they meet. So you definitely want to make sure you're doing more than one point, more than, do a couple points on the line. Okay, this one starts at 3, 1, 2, 3, and it goes down 1 over 1, down 1 over 1, and actually we'll be able to see where they meet right like that. But when you do these on Delta Math, you still have to complete the line, so we're going to complete it on our paper as well. Okay, and then the point where they meet is the solution, so all we're going to do is write the ordered pair of that point right there where they meet, and that ordered pair is over 3, and then we didn't go up or down at all, so 3, 0. That's the answer. That's the solution to the system. Okay. We'll do another one, and then I'll have you do one on your own. This one is y equals -x plus 7. And y equals 2x minus 2. Okay, so both of these are already in slope-intercept form, so we don't have to solve either one of these. We can just graph them. So for second one, my y-intercept is -2. My slope is 2, which I need to make into a fraction, so I put it over 1. This top one, my y-intercept is 7, and my slope is again -1, because there's a 1 right there, and then we just put it over 1 to make it a fraction. So I start at 7, which is way up here at the top, and then go down 1 over 1, down 1 over 1, down 1 over 1. Grab my straight edge and draw a line. And my second line, I start at 2, go up 2 over 1. 1, 2, 1, 1, 2. Is that right? Up 2. Oh, this should be, sorry, this is I see what I did. My y-intercept is a -2, not a +2. See the negative right there? See, I make that mistake too, you guys. Okay, so -2, up 2 over 1, up 2 over 1. I knew because it was supposed to meet, and it wasn't going to. That's why. It's supposed to meet at a nice point that wouldn't give me a fraction or a decimal. Okay, and then my solution is the point where they meet. So right there, whatever that ordered pair is, and it is 1, 2 over 3, up 1, 2, 3, 4. So 3, 4. That's the answer to that one. Okay, you guys do this one. So the system of equations is y equals 2x minus 5 and x plus 2y equals 10. Okay. All right, and I will tell you that the solution should be 4, 3. So solve both of them, graph them, and make sure that's what you get. You should be meeting at 4, 3. But do the work, okay? So you know what you're doing. Okay, that is solving systems by graphing. So now let's talk about solutions, like determining if an ordered pair is a solution to a system. So you're going to have two equations. Now, systems can have more than two equations. They can also have more than two variables, which honors will find out later. But for now, we have two variables with two equations. Okay, so if this ordered pair that we substitute into the equations makes both equations true, then it is a solution. That's what this box is saying. If both are true, then it's a solution. If one is true and one is false, meaning like, let's say this, we're talking about this one, let's say that this ordered pair makes this one true, but it doesn't make that one true, so we have one true and one false, then it's not a solution. They both have to be true in order for it to be a solution, not just one of them. And then obviously if both are false, then it's definitely not a solution as well. Okay, so we're going to try a couple here. All right, so all we do is substitute in substitute the ordered pair into each equation and make sure the left equals the right. Now remember, with an ordered pair, the first one is an x and the second one is always a y. So I'm going to do this equation first. So 3 times 0 minus 7 times negative 4, and I want to know, does that equal 28? If it does, then it's true. So 3 times 0 is 0. Negative 7 times negative 4 is a positive 28. And 0 plus 28 is 28. So 28 does equal 28, so that's true. So one of them's true so far. Now let's try it with the other equation. So my y is negative 4 equals 9 times 0 minus 4. Negative 4 equals 0 minus 4. So that means negative 4 equals negative 4, which is also true. So this is a solution. So 0, negative 4 is a solution to the system of equations of these two equations that are listed right here. Okay, let's try this one here. So again, this is x, this is y. So I'm going to try this equation first. So 6 times y, my y is 7, so 6 times 7 minus 2 times x, the x is 14. And I want to know, does that equal 15? 6 times 7 is 42. 2 times 14 is negative 2 times 14 is a negative 28. Does that equal 15? Well, 42 minus 28 is not going to be 15. I can tell you that much, at least because they're not odd numbers. But let me do my math. 42 minus 28 is 14. So we get 14 equals 15, which it does not. So this is a false. And so remember, even if we have just one false, it's not a solution. So I don't even have to check this other one. This is not a solution. Okay. If one of them is false, then it's not a solution. You don't even have to check the second one. But you do have to check the second one if the first one is true, because they both have to be true. Okay, so you'll have a couple of those on your assignment. When you guys do this on your assignment, I actually had to create those questions, so you only get 2 chances to get that answer right. Okay? All right, finding solutions from graphs. What ordered pairs are the solutions of the system of equations shown below? Remember, the solution or solutions to a system of equations is the point where they meet. Well, in this case, they meet with more than one point because it's not a system of linear equations. One of them is linear, right? One of them is straight, but one of them is curved. It's a quadratic. And so this is still a systems of equations. It's just that they're not linear equations like we were dealing with up here. Okay, these are linear equations right here. They just make straight lines. But you won't always have straight lines, so I figured we'd introduce them this way. So the ordered pairs that are solutions to this system are the point or points where they meet. So if I'm looking at this one right here, I can see that they meet in 2 different spots, right there and right there. Now the solutions are their ordered pairs. So all we do is write the ordered pairs. This ordered pair right here is over 2 up 3, so 2, 3. And this ordered pair is over 5, and then it doesn't go up or down at all, so 5, 0. Okay, so there's just 2 of them. Pretty easy, right? This one right here, again, they meet in 2 different spots, one here, one here. So this one has 2 solutions as well. This one right here is back 1 and it doesn't go up and down at all, so -1, 0. And then this one right here is over 2 and down 3, so 2, -3. That's it, guys. That's all for lesson 6.1. It's a pretty easy lesson. This is probably the hardest part right here, is substituting these in and seeing if the left side equals the right side. But as long as you can tell which one is X and which one is Y, you should be pretty good there. And then just make sure you put, you're still, making sure that you put those into slope intercept form, and you should be good there as well. Okay, guys, have a great rest of your day, and make sure you do the assignment. Thanks. Bye.